Okay, remember that I say there are there are phase, there are line. Okay, what is phase, what is line? Okay. Okay, so I take here. The next part is the phase and line. So what is phase, what is line? So for phase, okay, phase, line, star, delta. So phase, line, star, delta. Okay, star connection. Okay, I show you at the load side. Okay, star. Okay, for star. Okay, sorry, this one should. Okay, we start with star first. Okay, if you look for star, if you look here, the voltage, there are two types of voltage, either positive, negative, A, B, C. Okay, VAB, VBC, and lastly, VBA. Okay, so these are line voltage. Okay, line voltage. How about the phase voltage? This one is, remember, neutral always negative, negative. VA, okay, and VBN and VCN. Line voltage is basically not equal to V phase. Okay, V phase is VAN, VBN, VAN, VCN, VCN. Okay. For line voltage is basically VAB, VBC, and VBA. Okay, line voltage is not the same with phase voltage for star connection. Okay, how about current? For star connection, the current for phase and line, okay, is the same. V phase is equals to V line. Okay. For delta connection, if you look here, delta is okay. A, B, C. So remember how to draw? For voltage, this one VAB, VBC, and VBA, VCA. So basically, V line is just equals to V phase. Okay, if you look here, V line and V phase is the same. This is the line, okay, between the line, and this is the phase. The phase is basically between the load or generator. The line is basically at the wire. How about the current? If you look here, the current is This one is IA. Okay, this one is IB. This one is IC. This one is line because it is at the line. Okay, the wire at the wire. So sorry, this one is I. Okay, this one is I. So I line, which is IA, IB, IC, is not equals to I phase. So I phase is basically, remember, positive sequence A, B, C. Move to here. So I, A, B, I, B, okay, from B to C. I, B, C, and C, A. I, okay, from C to A. Okay, remember, the current move from here for load. For generator, make sure you flip it from A to C. Okay, I, A, B, I, B, C, I, C, A. Okay. So you know the difference. Basically, for star connection, voltage is the same. Okay, for current is for voltage is different. For current is the same. And for voltage, for delta connection, voltage is the same. Current is the different one. That is why it's good for you if you draw it, because you still not familiarized with this circuit. So if you're not familiarized, better to draw, because if you draw it, you will see the difference. Okay, it is much more clear to see the difference. Okay.
Doctor, may I ask?
Yes.
For the V phase for the star connection, why only got VAB, VBC, and VBA? Why did not have VCA?
Oh, sorry, this one.
This one, the line CA or BA?
CA, sorry.
Okay.
Yeah. It's harder to write in the drawing board actually. Okay. This one is CA. Okay, remember A, B, B, C, CA. Just remember the sequence.
Okay, thank you, doctor.
Okay, welcome. Okay, we continue. So basically, this is what I explained before. The line. Okay. So if you read this, it's basically what I have explained. Okay, this one is phase. This one is phase. And this one is phase voltage. Okay. And this one is line voltage. Okay, line voltage. Okay, this is one is line voltage. And for the current, okay, for the current, line voltage and line current is the same. Okay, that is just what I have explained. For slide, is much more difficult to understand because it is in word. Okay. So this is the relationship. Okay. Like I said before, phase current and phase voltage, phase current and line current is the same. Okay. So how to calculate? Okay. Of course, you have to know what is the difference. Okay, you already know the difference here. Okay, this one is not the same. Okay, this one is not the same. This one is not the same. So how to calculate this? What is the difference? Okay. Okay, this one, what is the difference? So just to simplify your understanding, okay, I write this back. I line is equal to I phase. Okay, the important part is Okay, for your course, you only see balance load. Okay, let me move here. Okay, you have load for three phase load. Okay, this one is phase, three phase load. Three phase load is basically have two types, balance and unbalanced. Okay, balance mean that okay, ZA equals to ZB equals to ZC equals to Z. So basically, the load from at A, okay, the load here, okay, the load here, and here is the same. Okay, the load is the same. So what that is mean by balanced load. For unbalanced load, ZA not equals to ZB and not equal to ZC. Okay, that is the difference between balanced and unbalanced. So the best part about this is your course only focus here. So you will not focus here. So balanced load is basically easier. Okay, you just calculate one and you get the answer. And the formula is also much more easy. Okay. So what is the difference? So here, okay, the difference is basically V line is equals to square root 3 V phase. So that's it. What is the difference? It's just V line equals to square root 3 V phase for balance load only. Okay. For unbalanced load, you have to use the different formula, but for balanced load, you have to use this formula. This is much more easy. Okay, and how to derive this, you need to know, because it will be asked in final. Usually, it will be asked in final. So how to derive? Okay, this is how to derive. Okay, so basically, okay, you have VAB, which is VL, line voltage, equals to, okay, VAN minus VBN. Okay, if you draw this, okay, this one is V phase. Okay, okay, this one is V phase. So if you draw this star connection, so A, B, C. Okay, this one is VAB. This one is VAN. Okay, this one is N. Okay, this one is negative. Okay, positive VBN. Okay. So VAN. Okay, remember Kirchhoff current law. Okay, the Kirchhoff voltage law. You do a loop here. So when you do a loop, okay, this one is negative, this one is positive. Okay, when you do a loop, wait, my pen doesn't work. Okay. So when you do a loop here, so you meet negative, so negative VAB, okay, you meet positive plus VAN, okay, you meet negative minus VBN equals to 0. So basically VAN is equals VAB, okay, This one is B. VAB is just equals to VAN minus VBN. Okay. That is how you get this. Okay. Sorry, my pen doesn't work. Wait a bit. Okay. That is how you get this. And remember, what is VAN? What is VBN? It is 120 degree. So VAN is equal to, VAN is just V, okay? Because remember that I said for three-phase system, the voltage needs to be the same. Okay, so basically, VAN is just V angle 0 degree and VBN is just V. Okay, this one is the same magnitude. Okay, okay, you can use V or VRMS. Either way is the same. Okay, and negative 120 degree positive sequence for B needs to be negative 120. So basically V 0 degree minus V 120 degree. So then VAN, this one is VAB. Sorry. Okay, VAB equals to, so V, okay, just, okay, if you convert this to a, okay, convert this one into a rectangular form, okay, you get 1, okay, okay, 0 degree, 1 angle 0 is just 1, and then minus, if you change 120 degree, okay, 1 angle 120 is just, you use your calculator, you get negative 0.5, don't forget negative, minus J 0.866. Okay, that's why you get this value. Okay, and lastly, use your calculator, you get this. Okay, so basically that is how you do it. Okay, just multiply by square root 3, and I forget to include here. Okay, so repair this a little bit. Okay, V line is just basically V phase square root 3 angle 30 degree. Sorry, this is the real one, okay? Because you have to consider the angle. If you look here, okay, you get square root 3 and 30 degree. Okay. If you look here, you get square root 3 and 30 degree. Don't forget about the angle. So basically, this one is the formula. VL is equals to V phase multiplied by square root 3 30 degree. Okay, how to do this? How to calculate this? For example, if given VAB is equals to 240 angle 120 degree. Okay. For example, given VAB is VAN equals to 240 negative 120 degree. So VAN is just V phase. So V line is equals to V phase square root 3 30 degree. So V line, okay, for this case, you look at the beginning. So A means that A, B. Okay, so VAN is just VAB. Okay, 240, okay, multiply by square root 3, and then the angle is, for example, is this one is negative 120, okay, plus 30. Okay, you get 240 multiplied by square root 3. You get 415.969. Okay, the angle is negative 120 plus 30 is negative 90 degree. Okay, that is how you use that formula. Okay, I give you another example. Okay, for example, the question is the system voltage is, okay, 415. Okay, if they give the voltage is 415, means that this one is line voltage. Always assume if they give the voltage, it is the line voltage. Okay, except if they tell it is the voltage source. If they say just voltage is 415, the system voltage is 415, means that it is the line voltage. To do this, you need to write VAB equals to 4150. Okay, so remember, A, you need to always assume that is 0. So VBC equals to 415, positive sequence, because positive sequence you need to 120 degree, and VCA equals to 415, okay, negative 240 degree. So the question asks you to change from find the phase and line voltage. Okay. Okay. Sorry, I cannot move my pen. Wait. Okay, if the question asks the phase and line voltage, okay, this is a line voltage. And how about phase voltage? Okay, how to calculate phase voltage using the formula. So V line equals to, okay, V phase square root 3, okay, multiply by square root 3 angle 30 degree. Okay, that is the formula. And because you want to find the V phase is equals to V line divided by square root 3 angle 30. Okay. So V phase is VAN equals to, okay, VAB. Okay, remember this one needs to be the same. Okay, VAB divided by square root 3 angle 30 degree. So equals to, okay, what is the value? 415. So 415 divided by square root 3, okay. Then the angle is VAB is 0 degree. Okay. Here VAB is 0 degree. So minus 30. Okay. Remember, if you divide, you have to minus the angle. Okay. If you have division, for the angle needs to be minus. For magnitude, just divide by as usual. So you get 240 point something, angle negative 30. Okay. How about VBN? So remember, VBC. Okay. So B and B needs to be the same. divided by square root 3 angle 30 equal to 415 divided by square root 3 angle, okay, VBC is negative 120 degree. Okay, remember? This one 120 degree. Okay. Minus 30. Okay, remember? Divide will become minus. If multiply, must be, okay, plus. Okay, remember? So just refresh. I think you learned this before in your metric, I think. So A, angle A, multiplied by B, angle B, angle theta B, theta. Okay, I use. So you have A, angle theta A, multiplied by B, angle theta B. Okay. So equals to AB, angle theta A minus theta B. And if you have A, angle theta A, divided by B, angle theta B, okay, just a refresh, okay, is equal to A divided by B, okay, angle theta A minus theta B. Okay, remember? You have to refresh back. Okay. So we continue again, this one. Okay. VBN is equals to 240 point, I don't remember, okay. Negative 120 minus 30 is negative 150 degree. Okay, the unit is volt. And VCN, okay, is equals to VCA divided by square root 3, okay, and angle is 30. So again, V C 415 divided by square root 3, angle is negative 240 minus 30. Okay, so you get 240 point something, angle negative 270 degree, or you can use 240 angle point some okay, 270, okay, or 240 point something angle. If you don't like the negative one, you can use the positive part, which is 360 minus 270. You get 90 degree. Okay, so that is how to determine your phase and line voltage for all the parameter. Okay. Okay, how about current? Okay. So you have the voltage, you find the phase current and line current. Okay, for star connection, phase current and line current is the same. So you don't need to worry. Okay, phase voltage and line current is the same. And to determine this, the line current, you need to use, okay, okay, how to get the current is basically I phase equals to V phase divided by Z phase, okay, divided by Z. Okay, it is important to know that you have to use phase. Okay, when you want to calculate the current, you have to use the phase. Okay, so I give you example here. Okay, example, they give that Z, okay, the load for each phase is 3 plus J4. So find line current and line voltage. Line current and phase current. So the question asks if what is line current, what is phase current. So basically, remember the formula, you have to use phase. You have already. Okay, I phase is equals to B phase divided by Z. So remember that you already calculate V phase. So you use one of the phase. So okay, because line current and phase current is the same, so just use IA equals to VAN. Okay. So remember the same. Okay. So Z is 3 plus J 4. Okay. VN is, what is VN? Is 240 angle negative 30, if not mistaken. Okay, check back your answer. Okay, this one, VAN. Okay, negative 30 divided by 3 plus J 4. So just use your calculator. Okay, make sure you bracket the answer. Okay, 240. Okay, negative 30. Okay, divided by 3 plus 4i. Okay. Wait. Okay. If you use your calculator, make sure you use bracket 3 plus 4i close bracket. Okay, remember, don't forget to close bracket and open bracket, and don't forget the negative angle. Okay, you get the answer, and make sure you use degree mode and complex mode. Okay. Okay, when you give the answer, make sure you use a polar form. Okay. So IA is 48 angle, okay, negative 83.13 degree. Okay, you get IA. Same goes here. Okay, and make sure you write when you do this. Make sure you write phase or IL is equals to IP. Okay, make sure you show this. If you just use this, you don't show the another answer. Okay, make sure you set that phase current is equal to line current. Okay, same here. IB, you have to calculate VBN. Okay, IB VBN. Okay, divide by Z. So equals to 240 angle. Okay, negative 450. Okay, divide by 3 plus J 4. Okay, you get the answer. And how to check? Okay, you get 48. The answer should be the same because you have, okay, you have balanced load except the angle. Angle should be 120 degree apart. So negative 203.13. Okay, this one just minus this one. Okay, if to check the answer correct or not, you have to make sure this one is negative 120 degree apart. Okay, same here. IC is equals to VCN divided by Z. Okay, use the same step. Okay, to get the answer. Okay, that is how to solve the star connection. Okay. And for delta connection, okay, Sorry, where is it? Okay, this is for star connection. How about delta connection? What is the relationship? So for delta connection, the relationship is just IL equals to IP, okay, square root 3 negative 30 degree. Okay, make sure you put negative. For star is just positive 30 degree, and for delta is current negative 30 degree. Okay, make sure you remember this formula. It will not be given. Okay, we will continue delta connection. Okay, next class. Okay, how to do delta connection. Okay, that's it. If you still don't sign in your attendance, please do so. Okay. See you again on Wednesday. And make sure you check your test. Okay, I put it in e-learning. Okay, you can leave the class.
Thank you, sir.
Thank you,
Okay,
Doctor.
welcome.
Thank you, doctor.
Thank you, doctor. Have a nice
Doctor.
day.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor.
Okay, you're welcome.
Doctor? Doctor?
Okay, yes.
Can I ask a question? But I need to share my screen to show.
Okay, okay, can.
Hang on. This one, doctor, this diagram, it's VB supposed to be negative 240 degrees, right?
Okay, VB is, wait. This one is positive sequence, right?
Yeah.
Okay, negative 240, okay.
But then why in between VB and VY, the degree there is going counterclockwise and it's saying 120 degrees instead of negative 120 degrees.
For VY.
For the VB supposed to be negative 240, right?
Negative 240 is actually 120. It's the same.
Oh, it doesn't have to be negative, meh?
Yeah, because you can use, it's the same actually. Negative 240, if you draw it again, it's the same as 120 positive.
But the but the arrow is like going in the positive direction. It's not supposed to go the negative.
It's okay. It's the same. As long as you said that is VY is negative 120, VB is negative 240.
Oh, okay. So it doesn't. Does this matter? Like this direction, does it matter?
Doesn't matter.
Or
As long as you show that VY is the downward, okay, and VB is the upper side. Yeah.
Okay.
Okay.
Then, doctor, can I ask about the test question? Because there's something that I'm not very sure of, like why I'm wrong there.
Okay. Okay. Yeah.
Okay. This question, doctor, is
Okay.
to identify the elements, right?
Oh yes.
So you said that these two are in parallel and these two are in parallel with each other, right?
Yes, correct.
But why isn't this considered series? Because if
Because it's only one. So you in series, it means that you need to at least two component.
isn't it like with this and with this? Because if this one, like let's just say it's
Yes, correct. You if this one already calculated together, it is in series. Actually, it's still correct, but how I can say it's actually the question is not too complete. Actually, the question it should ask at the current state of the circuit, what is the series, what is parallel. Okay, so
But-
if you answer this one in parallel, I will give you mark. No need to worry.
Oh, but I just want to understand because if here, if it like burns, these two, the current cannot flow through this, right? So I would think it's in series.
Can I draw this?
Yeah, sure.
Okay. So basically, okay. Okay, phi is not parallel with, not series with 1, or phi is not in series with, okay, not series with 2. But if you say that phi series in 1 parallel 2, yeah, this one is correct. Okay.
Okay.
So for this one also the same. Okay, if you said that phi is series with 10 ohm, 10 volt, 10 volt is not correct. Okay, because it is not in series. Same as phi series with 4. Okay, also not in series. Okay, but if you say that phi series with 10 volt and parallel with 4 volt, 4 ohms, okay, this one is correct. Okay, can you see the meaning of series and parallel?
I can see.
Uh,
But if I were to if I were to say that this 5 is in
okay.
is in series with this like all 4 of these elements, is it right?
Yes, but you have to be carefully write it. Phi is series with 1 parallel with 2 and 10 parallel with 4. You have to write like this.
Oh, okay.
Because you cannot just say that only one of the component, because it's this one, phi and 1 is not in series. Phi and 2 is not in series. But
Okay.
together it is in series.
Okay, understand this.
Okay, so be careful, a series, and this one I cannot teach too much because it's more on practical. You have to practice, determine the series and parallel circuit.
Okay, just wanted to clarify lah because I was like a bit confused.
Yeah, this topic is simple but hard to understand.
Yeah. Then doctor, this one I can't say it's all in parallel lah. Like 1, 2, 10, and 4. It's not together parallel lah. It's separate.
No, it's not in parallel. This one is just parallel. Oh, okay, this one and the 10 and 4 is parallel to each other, but not parallel to 1 and 2. Okay.
Because
If
of
you, huh?
why is that?
Because parallel, okay, the concept of parallel needs to start and end at the same node. Okay, if you can you delete this? I think I don't have any delete. Oh, okay, I have delete button. How to delete?
Wait, I'm using.
Okay, can you delete it? I cannot control it.
Can doctor? Is
Yeah.
okay.
It cannot be clear.
I clear already.
Oh, can you stop sharing and share again? I
Okay.
think it will delete it.
Okay.
Okay, so the concept of parallel, okay, the concept of parallel it. Okay, the concept of parallel is the start node and end node is the same. Okay.
Okay.
Start node and end node needs to be same. Okay. So this one is, I assume this one is node 1, node 2, and this one is node 3. Okay. For 1 ohm, okay, start and end is 1, 3. Okay. For 2 ohm is 1, 3 also. But for 10 volt is 2, 3. Okay, 4 ohm is 2, 3. Okay, and 5 ohm is 1, 2. So basically, start and end node is the same. So basically, if you look here, 1, 3 is 1 and 2 is parallel. So understand this concept?
Yeah,
Like this?
yeah, I understand. Now it's clearer.
Yeah. Okay.
Yeah, okay. Thank you, doctor. Just
Okay. Welcome.
one last question, if you don't mind.
Okay. Okay. Ken.
Uh,
Yeah, you have to stop sharing and share again. I think the system is cannot work properly. Yeah.
oh, okay. Hang on. This is the question 2B, doctor.
Okay. To be. Okay.
When they say want to find the voltage at V1 and V2, right?
Okay.
I took only this resistor because I feel like if it only passes this resistor, I shouldn't take into account all the other resistance.
Eh, you have to take account everything.
Why is that, doctor? Because it's only at the 3 kilo ohm. So
Oh, you have to calculate everything. Can I draw again?
sure, doctor.
Okay. Can you delete this? Okay. Cannot.
The line I just drew.
Yeah. I think you have to open and close again. If you delete it, I cannot. The mark still shown.
Okay.
Yeah. Can you share it?
Yeah.
Okay. 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 How to do this? So basically, you want to find V1, right?
Yeah.
How to calculate V1?
Find the.
I show you how to reverse the step. Okay.
Okay.
Okay. How to find V1? Using Ohm's law.
V equals to IR.
Okay. V equals to IR. So you need to know the current here. So I1. Assume this is I1.
Okay.
So you need I1. Oh, I1 3K. Okay. You need I1. So how to get I1?
By finding the equivalent resistance and then finding out the current that flows through the circuit.
Okay, that is one way.
Okay.
Because this you can use many way actually. There are multiple way. So another way is just use current division rule. Okay, remember current division rule?
Yeah.
So you have to find the resistance at this location. Okay, and resistance at this location. Okay, so this resistance is parallel. See, it is parallel. So 5K parallel with 20K. You get 4K, right?
Yes.
So this one is also 4K because it is in series. Okay. So basically 4K divided by 4K plus 4K and the current is 10 milliampere. So you get the current. So I think the current is 5 milli, right? 5 milliampere.
Yeah.
So 5 milli you already get I1. So 5 milli multiplied by 3K. You get 15 volt, right?
Yes.
That's it. That is the step. You have to reverse it back. Yeah. Same here. If you look here, if you calculate the current here, okay, there are multiple way. Okay, multiple way to do this. Either you use current division rule, 2 times current. Oh, Sorry, I cannot control.
Eh?
Okay, first you get this current. Maybe I tell you this one is I2. Not I2. IA lah. IA.
Okay.
So you calculate IA. IA is basically IA is equals to 4K, okay, divided by 4K plus 4K, 10 milliampere. So you get 5 milliampere. And then you want to get this current, you have to use current division again. I2 is just basically 5K divided by 5K plus 20K multiplied by 5 ampere. This one, okay, 5 milliampere. Okay, you get current division, and then after you do that, you can get this voltage. Okay, you get I2, you get V2. Same like here. You
Oh,
understand? That's
yeah.
that.
Understand.
Okay. That is one way. Another way, you calculate the total resistance, because okay, you can see here this one and this one parallel with this one. So voltage at source is basically same voltage as 20K. Okay. So you find R equivalent, you get this area is, okay, you get this is 4K, this one is also 4K. 4K parallel with 4K, you get 2K. Okay, 2 kilo ohm. And 2 kilo ohm multiplied by 10 milliampere, you get 20 volt. Right? Understand?
Understand, doctor.
Yeah. So because it is in parallel, so you automatically get V2 equals to 20 volt.
Okay.
So you have multiple way, because this is, like I said, is like an art. Okay, there is no procedure to do this.
It's
It's
like,
just randomly. You can use any type of theory.
okay. Okay. I understand now. Thank you so much, doctor.
Okay, welcome. Okay. See you again next class.
See you, doctor. Thank you. Have a nice day.
Welcome. Have a nice day. Okay,
Thank you,
welcome.
doctor.
Thank you, doctor.
Okay, welcome.